Have you ever noticed in old refrigerators that its light toggles on and off whenever you're about to close the door or open it? Well, how does it know that? And moreover, and if it does know if you're about to close or open the door, how can it then toggle the light on and off? And another case in fire alarms. When it senses smoke or anything that resembles fire, how can it then release the sound, buzz or whatever, or spray water for other models? Well, the answer is embedded systems. But what are embedded systems actually? An embedded system is a combination of computer hardware and software which is designed to do a specific function. And so it differs from other general use computers like personal computer, PC, or laptops, in that the main point of difference are the size, power consumption, complexity, and the number of functions it can do and the nature of it as well. An embedded system is composed of many parts, but we can group them into two subgroups. One is hardware, which is mostly composed of electronics and even more specifically ICs like microprocessors, microcontrollers, and registers and so on. Software as well, which is a very important part, which is mostly written by C and sometimes C++. But why these languages, you may ask? Well, these languages are very efficient because they can manage memory very well, and they are very close to the machine language, which make their code run fast and reliable. Well, why do we need embedded systems, you may ask? Well, they give us the opportunity to manage and control processes without having the need for human intervention, which is very beneficial in a lot of fields and industries, in any agricultural, automotive, or industrial like factories and so on. And also it can be very helpful in smart devices like smartphone, a home appliance, or any other smart device as well. Well, we have already talked about embedded systems, what they are and what they are composed of and why do we need them. But you may still have a foggy picture in your mind of what embedded systems are or what an embedded systems engineer actually do. So let's have an example, shall we?
And as we discussed before, here is an example of an embedded system. And this is the code written in C programming language. And all this code function is to do two things. One thing is to manipulate a number on an LCD based on an ADC value or an analog value, to be specific, and to handle interrupts and based on it toggle a LED on and off in a simulation. So here in Protos, this is the microcontroller, the mind of the embedded system. And as you see, there is a LED depending on an interrupt and a timer 0 and timer 1 in the microcontroller. It toggles every time, and when another timer also overflows, it toggles again. So you might see sometimes it toggles very quickly because a timer makes it toggle every like half a second, and another makes it like every 0.7 seconds or so. And the other function reading the ADC value is here the LCD with the number 511, and here is the variable potentiometer. So if we ever like change it, so the number changes, and as well if the number is higher, the number gets higher. Another example of an embedded system, more complex and advanced than the previous one. But this is not the main reason I wanted to talk about this example. The main reason is that I wanted to talk about the physical interpretation of embedded systems. We don't get the parts and connect them in a breadboard or jumpers, or like we connect them in any way that is configurable. We want them to be permanent, as they are going to be more fast, reliable in that way. And the way for that is using a PCB, a printed circuit board. And for that, with Protos, which is a very handy tool for that, this is the layout for the PCB. And this is a 3D visualization of what the PCB might look like.
So after what we have discussed, you should have a pretty good idea about what embedded systems are, why do we need them, and how we can actually make them. But if you have any ideas, suggestions, or comments, I would like to read them and next.